Here's a short video to introduce one of the pieces of software that we use in our course. This is a look at StatKey, which is authored by the authors of our textbook, the Locke family, which is a family of statisticians and educators of statistics. Some of the concepts in an introductory stats course can be a little bit abstract if just presented in the written word, right, in a textbook or in notes. So one of the things that research suggests is that simulation, visualization of these statistics early in the course can really help later in the course with some of the theoretical understandings that we need to look at. So this is the introduction to the StatKey software that I wanted to show you. And it'll help us, and I'll demonstrate it here in a moment, it'll help us visualize things like sampling distributions before we get into something like you see on the screen here, which is theoretical and discusses how repeated samples can create a sampling distribution that we can then draw inference from. But you can see there's quite a bit of terminology here. There are some formulas, things that would be more challenging if we didn't have an understanding from previous in the course with these simulations. So one of the ones I want to show you today is, suppose that Penn State was interested in estimating the true population proportion of students that were interested in Penn State sports. And that may help with apparel sales, ticketing, marketing, even something like amount of parking. So these types of things would be difficult to get after because there's almost 50,000 Penn State students. So what we would do is we'd sample correctly, randomly sample, and we'd ask people individually, are you someone who's interested in Penn State sports? Suppose I did that for 400 random students on campus, and 140 of them said yes, they did have some interest in Penn State sports. If I were to do it again for 400 people, I probably would not get 140 exactly. Next time it might be 136. If I randomly sample again, it may be a number like 150. If I continually do that, what I can do is I can build a distribution that surprisingly here I'm going to show you looks a lot like a bell curve, the normal curve that you're probably familiar with in some other setting in life. And then with that, we can use normal curve techniques to make inference, to make predictions. So what I'm going to show you here is what we call a bootstrap confidence interval using StatKey software. And this software, we have plenty of directions in the course on how to run it. There is support on their website as well. Of course, there are YouTube videos, but if you stay in our course with our notes, you should be fine. And then you can certainly ask your instructor for additional support. But the software does come with some built-in data sets that you could use. Now remember, we're looking at a proportion, so this is all going to be qualitative data. Are you in favor or not of Penn State sports? Things like, are you a Phillies fan? Yes or no. Are you on a prescription medicine? Yes or no. Those types of things, right? So what I can do is I can edit the data, and I can say that I had 140 people out of the 400 stated that they had some interest in Penn State sports. You can see that that's 35%. Again, I want to reiterate, if I randomly sample 400 again, I'm likely not going to get 140. There's going to be variation, which creates a sampling distribution. What we're going to simulate here is what's called a bootstrap. And a bootstrap will take these 400 people and it'll ask them, we'll draw one at a time and see what their result was. Yes or no in favor of Penn State or interest in Penn State sports. Every time they are asked, they are put back into the sample possibility. So they are with replacement. And what happens is when I do this over and over in a simulation, you're going to see a bell curve appear here. So what I'm going to do is I'm going to take those 400 and I'm going to randomly sample from them with replacement. And if I do that one time, you can see this time out of the 400, 133 were yes, I was in favor or interested in Penn State sports. And that was 0.333 as a proportion, and that was plotted. If I do that again, This time it was 136, which is 34%, and I plot that. And as I go, this average of all of these is updated here with this triangle looking pointer and the value underneath it. And I do it again. That time I had 142, which is 35.5%. And again, I got 36.3%. And it would take a while, but it's nice to have this option to see it actually populate and understand what's going on. I'll do one more. I got 33%. But we do have the option of generating 1,000 of these at a time, and we usually ask for a total of 5,000 or more so you get a good simulation. But if I did 1,000 more times, so 400 sampled with replacement 1,000 times, I start to get something that looks like a bell-shaped curve, approximately a normal curve. And if I do that, as you can see, up around 5,000 times, I have a real good representation of what the theoretical sampling distribution would be for this proportion. At this point then, I have what's called standard error approximated. That standard error is 0.024. That is a measure of variability. And now that I have this simulation, I can actually say, let's try to build an interval, which we call a confidence interval, to estimate where the true proportion of Penn State students interested in college sports lies. So later in the course we'll talk more about a confidence interval, but right now what I did is I created a 95% confidence interval to estimate the true population proportion of those interested in Penn State sports. Turned out that it's between 30.2% and 39.8%. So I could then say that I am 95% confident that the true proportion in the population of Penn State students that are interested in sports, Penn State sports, is between 30.2% and 39.8%. And then from there, we can make marketing decisions, ticketing decisions, parking decisions, that type of thing. That's what inference is all about, because we couldn't get at the 45 or 50,000 people that are in attendance at Penn State. And again, the simulation we work on early in the course so that when later in the course, when we get back to the theoretical underpinnings, it makes some sense that there is a foundation there for students. Hope that was helpful.